Welcome back, Programming 12. We are going to be making it so that our tic-tac-toe game is going to be forced to take turns. As it is right now, if I were to run it, of course I run the server first, and then I run the client. Check out this crazy game. I could be like, oh, I win. And if the client was slow, he'd be like, no, but I can't do anything. We actually don't have any win condition built into this project at the moment, but we're not going to go there today. We're going to instead be focusing on how do we make it so that whichever one goes first, that they are, going to have to click, and then the other person gets to play afterwards. Wait, I'm not explaining this well. Let's make them take turns. Let's make it so that, let's say the server goes first, so they're ready to go. When they go, then it becomes the client's turn, and then the server can't go again until the client makes a move, and so on. We'll also make it more visible. I think we'll do some colors to make that a little more visible. Let's go ahead and go to colorlovers.com, get some red and green. I don't know, it would be a good red for, hey, look at me, I'm, ready to play, and red as not ready. It's not my turn. Let's see, red and green, red and green. Let's just search red, green. What do we get? Those are not bad. Ooh, they're so too bad. I want to make sure they're pretty visible still. Everything's still visible. These are pretty nice, eh? Chic. Yeah, well, I'm not going to spend too much time looking for it. I'll probably just pick these ones here. Alright, so I'll probably do the green and the orange, I guess? I don't know, whatever. I'll just quickly grab those colors. I'm not sure how to do that now. Stop. There we go. So I'm going to bring in the, what is this one called? The mellow. I don't know where the name went, but that's okay. We'll go bring that in. We're going to have to put this in both of the different ones. So the color green equals hashtag bloop. And then I'll go with orange, mellow me. Oops. Color orange equals that. Alright, and I have to bring that over to both of them because we have to mirror this on both sides. Alright, so we got an orange and a green. This will mean waiting. This will mean our turn when it's green. Green means go. We also have to have a variable that will remember what turn it is. So I'll make a Boolean variable. It's either true or false. I'll make it, it's my turn. It is my turn. And it'll start off as false for the client, and I'll start it over here as true for the server, which means we're going first. I guess I probably should put my import statement at the top there just to keep that clear. Okay, so basically I only want to act on a turn if it's my turn is true. So let's build that in. So where is it that we take moves? So we take moves in this part here. So not only does it have to be that we're clicking on the correct location, but we also have to, it also has to be our turn. So I'll just add that in. So I'll say if we're clicking on an empty row, actually we'll put that first. If it's my turn equals true and this. So I can only take a move if that's true, and I'm clicking on a non-empty square. In fact, I don't even have to say equals true, because a Boolean variable is true or false, so I can just say if it's my turn, and we're clicking on an empty square. This reads more like English, so I think it's a superior way to code, not just because it's shorter, but because it's already more descriptive as it is. So I'm going to put that in there, and I'm going to do the same thing on the other side. So if it's my turn, and that. And of course, if I do take my turn, that means it's no longer going to be my turn, so I have to set it to false. So then it's my turn equals false. And last but not least, I guess I have to have a way to have my turn returned to me. So when I receive a message in the draw function here, so if I get an incoming move, I should make it my turn again because the other person has taken their turn. So it's my turn equals true. All right, so now both of them have that. Last but not least, actually, very last but not least, I'm going to also add in the fact that I want our background to reflect it. So I'm going to say if it's my turn, I am going to make the background green. Else, I'll make the background orange. And I'll do the same thing on the other side. All right, I don't know, this is going to work. Let's hope. So I'll run the server. Oops, I accidentally ran the client first. Run the server. It's green, and I'll run the client. It's orange. So let's try to take a move on the client. Looks like I cannot. Okay, good. So I'm going to try and take a move on the server now. And it did, and look, it turned orange. And now over here is my next move, so I can go here. Oh, and it seems to be going back and forth now. And I can do all sorts of good things. Oh, snap! We got them locked in! No! It's a little anticlimactic, the fact that you cannot win. I mean, you can still keep playing. Now it's green. Like, you could continue on, but I'm not going to worry too much about that for this project. I think having a nice little completion to the project as sort of an example of how it works is a good place. However, if you're interested, it's probably not that hard if you want to make a testing you win condition. I don't know of any fancy way. It's probably just a bunch of if statements checking, if these different combinations of rows and columns and diagonals are all the same number, and I have to make sure they're not 0. Because they already start as the same number. They all start as 0. So you'd have to check they're not 0, and they're all the same number on each row and each diagonal with some kind of if statements. I don't think there's really a more efficient way to do it. Maybe you could write a loop to go through it, but it wouldn't actually be, I think, better code. It'd just be different code. So yeah, if you'd like to try that out, you're more than welcome to. Last thing I'd like to show you is just a slightly more advanced way of doing the loops. So if you are doing these while loops, this is great. While loops are fine. However, there's a faster way of doing it. It's called a for loop. So instead of doing sort of all this extra work with these if statements and stuff, we can actually make these 2 different for loops. So a for loop, basically, if you have a while loop, let's just actually open a new sketch. So a while loop usually looks like this, right? Int I equals 0, while I is less than some number. We'll just say 3. Do something, and then I plus plus. Right? That's sort of what we've been doing for our while loops. It turns out that there's a shortcut way to write this. It's called a for loop, and it looks like this. So for, now, it's basically like saying a while loop, but all these guts here are going to go inside of the parentheses. So you can put your int I equals 0 here. You can, and then you put a semicolon, and then you put your condition to keep on going here, and then you put your incrementation here. The incrementation always happens at the very end of the loop. It'll always happen, like no matter what amount of code you put in here, it'll secretly go right afterwards. Well, not secretly, but it'll insert this at the end. So you can see that while this takes, several lines, this takes, essentially 1 line. So it's a nice compact way of writing it. And another thing that's nice about this is we can condense all these lines of code into what's called nested for loops. So instead of just having this if statement to like reset us back to the beginning, we can just stick another for loop inside of our for loop that will sort of go across the row, and then the outer for loop can go down the columns. So we can convert this into 2 for loops. So check it out. Instead of writing all this, I'm gonna keep it on the screen just as I go forward. It won't take many lines. I can do 1 row for the 1 for loop for the row. So I'll say int row. It won't let me do this technically because I've already done that. I just want to keep it on the screen. Equals 0. Row is less than 3. So we got this part, we got this part, and then we just need the row plus plus, row plus plus. And then in the nested for loop, we do the column. Int column equals 0, column is less than 3, column plus plus. And if we do this nested for loop structure, we actually don't need anything more. The reason is because when we get to the end of the row, so we go through each column in the row, 0, 1, 2, the next time we come back around to do it again, it'll automatically reset. And the row plus plus will happen after here automatically after we've gone through each column in the row. So these, essentially like, 4 lines of code, or really 2 lines of code of the for loop will do the whole work of this. All we need to do is bring this over. And then we can get rid of all that stuff and we have the nested for loops. There you go. And actually, technically we don't even need the braces because we only have one thing inside, so we can make it even tighter. So that's the nested for loop. This is generally how people will do grid processing in pure Java, or actually any programming language. It's tighter, right? It's just tighter code. All the nuts and bolts are sort of centralized in one place, and a nested for loop means we're repeating the repetition that's inside, so it's pretty nice. So I invite you to put in a nested for loop to try it out yourself. I'm going to close this. And you can just basically copy and paste it, replacing all those lines of code, making things a little bit tighter. So yeah, the nested for loop is great. A little bit confusing though, so please feel free to ask questions if you're not too sure about it. And thanks so much for all your hard work that you're doing in all your courses. I know it's not easy, and I know it's a little bit a little bit crazy to be doing all this online learning. So thanks for your perseverance. Okay, have a great day, everybody. Bye-bye.